Okay, so now we're recording. We're listening to FT8 activity on 40 meters. It's 9:20 local time on Wednesday night, May the 15th. We have Gary's ICOM 7000 here. This is one of the computers we're going to use for field day. All we're using for an antenna here in the house is a G5RV that is coiled up. And we're seeing signals, well, as you can see on the screen, we're seeing a number of signals. So what we're looking at here is the WSGTX software. This is the software that does FT8 in addition to a number of other digital modes. We have the waterfall window down here at the bottom of the screen. Pan down if you would there, Mary Jo, and let's get the bottom of the screen in the shade. There we go. And then the main window is up here where you have two lists. There are, on the left, we have everything that we're hearing that's coming through. On the right is everything that we're hearing on the specific frequency that we're monitoring. And just for grins and giggles, we'll just pick a frequency here to monitor. We'll set it on about 1030 hertz. But that's really not all that important. We're going to hear everything that's in our passband. So this, as you hear probably in the background, the sound of the signals, they're warbling tones, and each different frequency, it sounds like a chorus of tones, that represents several different stations transmitting all at the same time on different frequencies. And as you see in our list, we're decoding many of them. So one thing you'll notice about decoding is that we seem to decode all of these at about the same time, and the reason for that is FT8 is descended from meteor scatter modes, which means that the transmit and receive periods are very regimented. They're on 15-second intervals so that stations are not transmitting at a lot of different times and stepping on each other and all the problems associated with that. So one of the prerequisites to operating FT8 is we have to have a very accurate clock on our computer, and we have a special program running on it that will synchronize the clock with an internet time server about every 15 to 30 minutes. So what we're seeing again here is every 15 seconds, all of these signals that we see in our waterfall here, all these bright spots in the waterfall are decoding into these messages. We have people calling CQ, we have people answering CQs, we have QSOs in progress. It's kind of hard for me. I'll turn monitor off so it'll freeze the window for a minute. We'll just take a look at everything we decoded in that last round here at 9:22 and 30 seconds. We have KM4UJI calling YV5GPA. YV5GPA is in Venezuela, KM4UJI is in Florida, Grid Square EL98. We have someone in South Carolina calling a station in the Ukraine, UR8IDX. We have a station in Illinois calling CQ N9WQP. We have KY0L sending a signal report that's -11. And you say, well, what kind of signal report is that? That's not 559 or anything. What that is the signal to noise ratio in dB. That's 11 dB below the noise level. And we'll talk in a minute about how we know. Well, we'll just go ahead and talk about it right now. One of the other columns here, we have the messages that we're decoding. We have the time stamp, that's hours, minutes, seconds, all mashed together. The next column is dB, and what that is what we're receiving in signal strength, signal to noise ratio. So for instance, N4BMX in FM09, which I believe is going to be in Virginia, is 19 dB below the noise level. That's a really weak signal, and probably would not be able to hear that by ear unless the band was extremely quiet, and maybe not even then. Most people with decent hearing, about -12, 13, 14, 15 is about as low as you can go with just your ear. Just looking at some of these other messages, again, we have people calling CQ. There's someone sending the initial report. Someone else calling a Russian station with their grid square. Here's someone who has received a report. You have N4XJJ who's in a QSO with HI3MFR in the Dominican Republic, and he has received HI3MFR's signal report. So now he's going to, instead of just sending a number as a signal report, he's going to send a signal report and an R for Roger, meaning that I've received your signal report, now here's your signal report. And if HI3MFR gets that signal report, HI3MFR will then send a message that says RR73, Roger 73, meaning that the contact is now complete. Let's see if we have any RR73s. There's an RR73 there. So K0KP just finished their QSO with the station in Sicily, IT9JMR, RR73, meaning I've received your report, 73, we're done. And then the other station may, as KC2G did with this station from Moldova, sends ER3KS KC2G 73, and that means that for sure the QSO is over. So that's the normal operation mode of FT8. If we wanted to transmit, which we can't do with the antenna here in the house all coiled up, that'd cause more than a few problems. But we would click this button that says Enable TX, we would call CQ, and every 15 seconds we would send our CQ message. It takes about 12.5 seconds to transmit, and then we would wait for a station to call us back. And if a station called us back, in our monitor window we would see our call sign, their call sign, and the entire message would be highlighted not in green but in red to let us know we were receiving a call. Now there's a checkbox down here that says call first. If that checkbox, if you'll pan down there a little bit, Mary Jo, and we'll get that on video, the call first checkbox is right there, and if that's checked, if someone calls us, the software automatically on our next go round will call them back and give them a signal report, and the QSO will progress automatically without our intervention, even if repeats are required, until we send RR73 or we receive. If we receive an RR73, we will send a 73. And here's an interesting CQ there from an Aussie who is portable in W8 land, something you don't see every day. But the software, once someone calls you, if you're calling CQ and someone calls you and you have call first checked, the QSO will proceed without your intervention. If you get into a situation where many repeats are required and you go 6 minutes without any kind of manual interaction with the program, there's a watchdog timer. If you'll look down in the right corner, it says WD6M. If that timer counts down to 0 minutes, the status box in the lower left corner will turn red and say runaway transmit watchdog, and it will not transmit anymore until you click the enable transmit button again. That's in case you're operating FT8 at 3 in the morning at field day and you fall asleep. Much like I suspect someone did on 80 meter CW last year and was 40 over S9 and would not answer about a dozen calls that I gave him. So that's one of the purposes of the transmit watchdog. But again, this is the normal operating mode for FT8. Now, field day will work a little bit differently, but not too much differently. The only difference will be in the exchange. There won't be grid squares, and there won't be the signal reports. There will instead be the field day exchange. 3 Alpha Alabama, 8 Alpha Vermont, 4 Alpha San Diego, whatever the class and the section are, that's what will be exchanged in the field day exchange. Again, the software should just take care of it. When you complete a QSO, it will tell N1MM logger that you completed a QSO and it will get logged. So that is a whirlwind tour of FT8. Hopefully some of you are now interested enough to give it a whirl at field day. We'll have about 3 stations, maybe 4 stations that will be FT8 capable this year at field day. So come on out and give it a try.